pretty accurate, I would say. It looks like me. And we can just use compute. Yeah, so the generation finished, and as we can see here, it created like a movie poster with FLUX.1 LoRA written on it with my face on it. So it's actually pretty decent. And hi everyone, in today's video we're going to be training the FLUX.1 state-of-the-art image generation model. The motivation behind this is that during the process of preparing my YouTube videos, basically I need to create a thumbnail. The first two videos, the thumbnails that I created using basically DALL-E. I just give it the topic of the video and it just like generate an image. I'll crop it, put it in the correct aspect ratio, and then I'll just put it on YouTube. In my recent video, I tried a new method, and basically I used like Mid-Journey and like face swapping to create the thumbnail. And however, like I didn't like it. Like it took me a lot of time, like a lot of basically like prompting and so on, and it didn't give me the results that I was looking for. So that's why I took a look at the FLUX.1 model, and especially because the previous models struggled a lot with the face swapping part. So basically I would just like, I want to put my face in the video and it would basically be challenging to do so, and I don't have any experience with editing whatsoever, so I don't want to do that on my own. I just want to basically have an AI tool or train a model to do that for me. So in today's video I'm going to be showing you, taking you through the process that I used to train this model on my images, basically create realistic and cinematic and beautiful looking thumbnails. So let's get into it. So in this video I'm going to show you two methods. The first one is basically training it on cloud GPU from runpod, and we're gonna train the model. Like we're gonna run the training scripts, build a data set, and train the model to generate images featuring ourselves. The second method is if you actually do not have the technical expertise and you do not want to go through the hustle of basically renting cloud GPU or doing the training by yourself. The second method is gonna be by basically using an online tool called like FAL. So we can basically on FAL we can train the model. So they host basically the models for you on their GPU infrastructure, and you can basically train the model and upload the data set just on the UI. So if you prefer the second method, it's a little bit more expensive, but the first method is going to give you like a complete flexibility on the model, and you will be able to generate as many images as you want because you basically control the code, you control everything. So let's get into it. So here we have the repository of the XFlux, and we're going to be using a method called LoRA. So the main idea of LoRA is that we project the weight matrices into a lower rank, and we take advantage of the fact that often weight matrices share like a low intrinsic dimensionality, and by decreasing this dimensionality we're not gonna lose lots of the performance of the model and lots of the accuracy of the model. So here we reduce the number of parameters without losing the context of the model. So this is basically the main idea of this, is to save compute. So during the fine tuning process we do not need to have like extremely powerful GPUs, and we can just train it with one GPU. So that's what we're going to be using. So for that we're going to be using the training scripts in this repository. So the first step is that we need the GPU, actually, like the cloud GPU. For that, I'm going to be using runpod. So we need to deploy a new pod. So we click on deploy. I want to choose a GPU that suits you. I'm going to choose this one because it's sufficient. Like I know that the VRAM is sufficient, and I'll just like click on deploy on demand. So now it's deploying. Yeah, so we can see here I have two instances, one that I already had before, and this is the new one that we created. Yeah, so now the instance have started. However, one thing that I forgot to do is that to edit the volume size of the instance. So now what happened is that we're going to have access to a machine, to a remote machine that has H100 SXM GPU in it, and I need some space to store the models themselves. So the model is about 23.8 gigabytes, and also we need some space to store the checkpoints. Therefore, I'm gonna assign like maybe 200 gigabytes here or 100 gigabytes. Just one thing very important to note is that there is a difference between container disk and volume disk. So the container disk is basically the disk storage that resets every time you restart your instance. So it's part of the container. So whenever you start the instance, a Docker container under the hood starts basically, and this is the storage allocated to that container. The volume, however, is basically stored somewhere else. Like the volume is stored on a dedicated storage. It doesn't get deleted when you restart your instance. So here the choice is yours. Do you want to store the models on the volume or on the container disk? Actually, I recommend storing it in the volume disk because, as I said, the volume will not be deleted after we basically restart the instance. However, for the container disk is also important. 20 gigabytes, like the default one, I think it will not be enough. So I'm gonna specify like 100. And now let's save the settings. Now the machine is restarting. So now the instance is running, as we can see. And now we can connect. I like to connect through VS Code because it gives me flexibility as I'm like developing on my local machine. So basically, to connect to this instance with VS Code, you're gonna go to the lower left corner. You basically you click connect to host, and then you want to configure the SSH. So basically now we want to go to the SSH configurations. So let's call it host Flux training YouTube. And the host name basically is the IP address. So here we take the IP address from here, copy paste it, and then this file basically is going to be generated for you when you create your account. And this is basically the private key location. And you're gonna store basically your public key in your runpod account. So I already have that. So by default, I'm actually using this. So I don't need that. I just need to know basically the user. So the user is root. So let's specify the user root, and basically we're gonna specify the port as well. So the port in this case is 142. Specify the port, and that's all. Now we can basically connect. I'm gonna get again to the lower left corner, connect to host Flux training YouTube, and click continue. And basically here we go. So now it's getting connected. Now we successfully connected to it. And now one more important step is that we need to go to the workspace, because the workspace directory is the one that is persistent. Once we restart the instance or we stop it, we're not gonna lose access to this folder. So that's why I'm gonna go to the workspace folder where we're gonna start our work. So now we go open terminal, we open a new terminal, and now we start working on this. So the first thing that we need to do, according to the installation guide, is that we need to clone the GitHub repository. So we copy this command, we paste it here, cloning the repository, and then you can create a virtual environment. I just like skip it because I have only one Python environment in this instance. I'm not going to be using it like for permanent use. So it's an optional step, and then basically we need to install the requirements. So we need first to go to the directory of the repository, and then we need to install the requirements. However, I think for training, we need to track our experiments. So to track our experiments, we're going to be using weights and biases. So weights and biases is basically a method for us to take a look at the experiments, at our like training loss, like the models that we're training. All the metrics during the training are going to be logged into weights and biases. And actually, the training script of Flux supports this, so we're going to be adding this. So we need also to install weights and biases as well. So now everything is installing. I just forgot to mention, I believe the type of instance that I deployed, it's actually PyTorch 2.2.0, Python 3.10, CUDA 12.11, Ubuntu 22.04. So this is the one I'm testing with now. So when you click deploy, when you choose the GPU, so which GPU, I will choose this one, and then it will take us here. So this is a template basically that's going to be, so PyTorch is going to be installed, Python 3.10 is going to be installed for you. So this is the one I went for. So just for you to keep in mind. And now, so now I need to run it once more because I added the weights and biases installation. Everything's going to be installed from the cache except the weights and biases. So now it's weights and biases is being installed. It got installed successfully. And now the next step is the training. So for training, we're going to use the test LoRa YAML file for the training configurations. So these are the training configurations. The image directory is the most important one here, which is the directory for the data that we're going to be using for training. And now I'm going to show you how we're going to construct the data set. But before that, let's take a look at some parameters that are important for us. So here's the image size. The image size 512 is fine. The higher resolution, the higher image size, the more quality the results will be, but it's going to be at the expense of the compute. So I have now like 80 gigabytes of visual RAM, and this is probably not going to be enough for 512 image size. So maybe I'm going to need to decrease it a little bit. So I'm going to show you how to do that. So let's now check actually the GPU that we have here. So I'm going to be logging the GPU information every second. NVIDIA SMI. So I have here, as you can see, we have the H100, 8 gigabytes of memory, and here we have like 81.5 gigabytes of visual RAM. Yeah, what other parameters that we need to take a closer look at? Basically, the number of training steps. By default, it's 100,000. For us, like, let's make it just 1,000, or this is basically going to be like how many steps we're going to iterate over the data images that we have in our training data. So, for example, if we're going to have like 20 images, and then the training steps we have 2,000, then every image is going to go through the model 100 times. And that's what I found to work well for me. So I'm going to keep it like to 2,000 and have around like 20 training images basically to train the model. I'm going to keep everything else the same except for the learning rate. So this learning rate is actually for longer number of steps because it's kind of a little bit slow learning rate. So we're going to make it a little bit faster, a little bit higher number. So I'm going to make it like 10 to the power of -4. So also, we need to change this. I'm gonna disable sampling. So sampling basically is gonna show you samples during the training of how the model is generating images over every 150 samples. So you can basically check the improvement of the images. However, I don't need to do that because it actually slows down the training. So I'm gonna just disable it. So the disable sampling equals to true. And I believe that's all what I need to do before moving to the dataset. So for the dataset, you need like images of yourself, because I'm going to be like asking it to generate images of myself to include in the thumbnail. So now the images are being transferred to the image. And the second thing we need to do is that we need to create captions for the images. So the captions of the images are going to be basically JSON files containing the caption of the image. In this case, it's going to be just like the trigger word for the model to know that it's me. So for that, I prepared 22 JSON files, because in this case I have like 22 images, and these JSON files basically contain just my name as a caption to the images. So every image and its JSON file should have the same name. And the caption should be in the following format: caption and then the name, which is basically your name or the trigger word where you want the model to recognize you and generate images with yourself. Then the next step is to basically create the Hugging Face token, because we need access to the FLUX model. So here's the FLUX model that we went to, and I already have access to it. Basically, if you do not have access to it, you just like here, you're gonna have basically a button that you press that you agree on their terms of use, which is basically that this model cannot be used for commercial use. So I just agreed to the terms and I have access to the model. It's already a million downloads in this month, so it's pretty much hit model for now. So I want to use this model, and for that, to just confirm that I have access to it, I need to basically log in to Hugging Face, to my Hugging Face account through this instance. So Hugging Face CLI login, and then it's gonna redirect me to this path to basically which can be just like a read access token. So FLUX.ai YouTube. I can just create the token, copy the token, paste it here. I just did Command V, and then I do not want it to be as get credentials, and now I logged in successfully. So now the system knows that I already have access to the model when it tries to download the model. So I think that's all what we wanted. Just one thing, as I said, that this number is going to cause the memory to overflow. So we need to make this number a little bit lower. So let's make it like 400. So 400, I think it's a good number or a good value, or maybe we can make it like 430. And now let's try just to run the training script. So we're gonna copy paste the LoRa one, the LoRa approximation one, and then I'm gonna run it. So now it's running. Now it's trying to download the model. So we already have all the images prepared, and now the models are being downloaded. Now we can see we already occupied 10 gigabytes out of the 80 gigabytes. And now actually the parameters are going to be loaded, as we see. Now they're loaded. They're being loaded now. We see how the memory is increasing. And now, yes, so now, as I told you, we need to track our experiments with weights and biases. And for that, it's basically here asking which account, or whether you have an account or not. If you do not have an account, create an account. If you have, just use an existing account. I already have an account, so I'm going to use the existing one. Select the second option. Now we go to the weights and biases to authorize. It's asking me to log in with my email. I'm gonna log in. And basically I'm gonna copy this code, just pasted it, and now the training is starting. So yeah, as you can see here, now it's starting training the 2000 steps with this learning rate. And yeah, it's gonna take around 16 to 17. However, I'm still not sure whether this learning rate is the best. However, I'm gonna keep it for now, so let's test with it. And I already have trained another version with another learning rate, which is 10th power of minus 3, which is basically like 10 times larger than this, which basically tells the model to learn like in sharper learning curve. And let's see which one works better. So this is what we're gonna find out. So now, until it's finished the training in 15 minutes, what I'm gonna do is that I'm going to show you the other method. So in the other method, we're going to be using an online tool for doing all of that, which is basically fal.ai. So in the fal.ai, you can go to the train FLUX LoRA fast. So I upload the zip file that I have, and now I put the trigger word. So as I told you, the trigger word is going to just be my name, which is like Hussein Yunus, and basically that's it. So the setup here is much easier than the setup there, and then we can start the training. Yeah, so the training is gonna cost like $2 per training run. So let's see. So I didn't change any other settings. Just worth noting that this model is optimized for headshots, so it's exactly suitable for my use case. So basically, it's been pre-trained and fine-tuned on faces, like, or headshots. So it's more optimized for faces, while the other one that we're training on the runpod version, it's more general purpose. So if you, for example, want to generate not faces but other things, you can upload your images and their captions. For example, you have some like some cartoon character that you want to have, and also you want for example to market some product. You can create the images and their captions and add them in a dataset the same way we've done here, and you can train it in this way. Or if you want to use this model that is like optimized for headshots, go ahead. So now the training is in progress. We can see the logs. So it will take around 1 minute. So as you can see, maybe the training here is actually even cheaper because it costs like $2 per run, while here it cost me this GPU costed me around like $2.99 for per hour. However, in 1 hour we can run, as you can see, like one run takes 15 minutes, so you can train it 4 times, so we can like train 4 versions. So we can train like four models for $3, while their 4 models will cost $8, so it's not cheaper practically. The inference here, in 1 hour you can have like unlimited, or in less than 1 hour, like you can have unlimited images, while there they charge you per image. Yeah, the training is complete now, and now we can run inference. So as you can see, we've done that like really fast. And now let's see if actually it captures me. So Hussein Yunus, just like I just put my name here, and it's it's actually like it actually captured my image. Like it works really well. So now we can generate the thumbnail. So for that, you can go, for example, to ChatGPT and tell it to actually create the prompt for you. So I have done that. I went to like ChatGPT and I asked it to create a prompt for the thumbnail with like cinematic views and so on, and it gave me a very detailed prompt. I'm gonna share the prompt with you. So here's the prompt that ChatGPT gave me. Design a cinematic and professional YouTube thumbnail styled as dramatic movie poster featuring Hussein Yunus. He is depicted in dynamic, engaging pose and blah blah blah. And I also told it to have like FLUX LoRA in bold. So now let's run. As you can see here, this so for $1 you can create 29 images for $1. So that's the cost for it. So now, as you can see, it's like it's pretty good. My face is pretty accurate, I would say. It looks like me, and yeah, that's it. It's actually very easy. Now let's see. Our model actually needs 10 more minutes. And now in this time, also I want to show you how you can actually like export this model and then use it in your local machine if you want. So what I'm gonna do, I'm gonna go back to the where we trained the model. So we're gonna go here. As you can see, there's the Hugging Face option. So for the Hugging Face, it's gonna prompt you to create a Hugging Face repository. So here you put your access token, and here you put the repository name, the new repository that you want to create. There's the description of the repository, which is like optional, and then the instance prompt, which is also optional. And then you click create on the repository. It's that easy. I've already done that. I've created this Flux custom model on Hugging Face, and the inference API actually runs that for me for free. So I can take the same prompt from here, 1 second, and the same prompt that we used there, and I can just paste it here, and we can just use compute. Yeah, so the generation finished, and as we can see here, it created like a movie poster with FLUX LoRA written on it with my face on it. So it's actually pretty decent, and I believe one factor is that in your images you want to have like some variety of images. So some of them you want to be smiling, for example. If you want in your prompts, you want yourself to be smiling. You also want to have like a close-up shots, and you want to have, for example, like mid shots. So like kind of have some variation in your images, and upload at least 20 images. Don't upload a lots of images, because it's not gonna be enough for the iterations to train on all your images. So 20, I think it's the is like the sweet spot that you want to go for. Yeah, actually one thing is that I specified the checkpointing steps to 2500, which was like the default value. So every 2500 steps is gonna save the model, but in our case the maximum steps that we have is 2000, so it's not gonna save any checkpoints. So basically I just left it, so it didn't save the checkpoint at the end of the run. So yeah, you need to make this 2000. Definitely you need to make this. So let's make it actually 1000. So every 1000 steps we're gonna save a checkpoint, and let's run the training again. Yeah, so I can show you also where you can track the status of the pod. So while the model is training, you should see in your runpod dashboard something like this. So the GPU utilization should be as high as possible, and that you basically like utilizing the most out of the resources, and same as the GPU memory. Also, like you need to be using it. So if you see that, for example, it's like less than that, you can basically increase the image size, or the batch size. Otherwise, like keep it as we set it. Here we see the CPU and memory, and here we see the container and volume. So basically you can see the resource utilization of your pod from the dashboard. So now the training is done, and now we're waiting for the checkpoint to be saved. As I said, now we're saving the checkpoints after every 1,000 steps. So in this case, we saved it at 1,000 and 2,000. So now we need to run the inference. As we can see here, it's also like have saved all the results and training loss into the weights and biases. So you can check that as well. And now we need to run the inference. So to run the inference, we go back to the repository, and we can use one of these inference methods. So we can use the conf.ai that they developed by FLUX.ai, or we can use the main script in this repository, or we can use a Gradio UI. So the most user-friendly one and most accessible one is just to use the Gradio UI. So for that, I'm just gonna copy this command, and instead of the model weights, I'm gonna choose the directory for basically our checkpoint, our latest checkpoint of the model. So I just gonna copy the path, and I'm gonna put it here. There's no module named Gradio, so we just install it. Pip install Gradio. Now we wait for the installation. And now we run it again, and here it launched it for us. So now this UI is hosted on our runpod instance, and we can see the generation options, and here's the prompt. So before putting the prompt, I'm gonna just put the load our LoRA version of the model into the LoRA options, and then I'm gonna see sane units. I'm gonna just compare just to see if it captured the object. Ideally, the other solution, our Flux with FAL solution, works better because it's optimized for headshots. However, let's see how this one performs. So let's see. Okay, it doesn't look like me a lot, and that one looks much more like me. So now let's test with the prompt about the thumbnail. And basically, let's see the result. Okay, so this is the result. It doesn't look like me a lot, like the other one. Like the one on the Hugging Face looked much more like me. It looked much real. And this is because, again, this model is a general purpose model. However, I'm gonna attempt one more try to basically fine tune it for 1,000 more steps. So what I'm gonna do is I'm gonna add here 3,000 steps. I'm gonna actually, we can also again like test another checkpoint. So what I'm gonna do first, I'm gonna check the 1,000 checkpoint, and if the result's gonna look like me. So now we go to the LoRA options. LoRA, let's load the LoRA and let's generate. Yeah, so again, it looks, I mean, it captured my beard, my hair a little bit, but not my like other features of my face. So yeah, I want to run it to train for more. So by default, it's gonna resume from 2,000 from this checkpoint. I'm gonna remove this checkpoint because I don't need it. And basically, yes, I'm gonna specify 3,000 steps. Let's run the training again. Yeah, so now as we can see, it loaded the checkpoint 2000 correctly, and now it's resuming from there. So it's not starting from the beginning, it's starting from the checkpoint 2000, and it's gonna take like 8 more minutes to complete this checkpoint. So I'll see you after it finishes training. So the training is finished now. So one more checkpoint has been saved on the 3,000 steps. So now let's try to run the inference again with the new checkpoint. Yeah, so now let's check on the newly trained version. And now this is the one that we trained locally. Okay, this one looks a little bit better than what we got before. However, this one is a little bit more accurate than this one. So for this, we actually need I believe, to train it for more steps. I suggest like 10,000 steps for better results. So let's see. Now we can generate again. It's gonna basically attempt to generate it from a different perspective. Okay, it's generated. So we can see here, like, this one is fine-tuned for a more like photorealistic like pictures, while this one is like a little bit different style, which is interesting. Okay, so it is actually capturing a little bit of my face, like, however, like for example, the eye color is not there. So now, like, I tried a different prompt. Okay, not so bad, not the worst. I think we need to train it for longer number of steps, and basically I think we would get better results. Again, you can also download the model that you trained locally. The checkpoints were saved, so you can download it locally and use it later, and upload it to Hugging Face, as we've done here. So that was pretty much what I wanted to show you. And if you'd like to know more about LLM-based agents and text-based agents, not only image-based agents, then check out this video, or this video here.